Okay, chapter 3.7 is about direct variation, and things vary directly when they change the same way. For instance, oftentimes your height and your weight vary directly. The taller you get, the heavier you are. If you add inches, you often add pounds. For instance, another way to look at that would be like for a tree. As a tree grows taller, usually the distance around the trunk gets bigger. So there's a direct variation. We look at that using a formula. Ooh, get my formula going here. Y equals kx. And the k is called a constant, but it's not spelled with a k, it's spelled with a c, which is just something to remember. It's a constant k. It doesn't change, but the x and the y do. For instance, if I were to make k into some number, say I have y equals 2x, and I make a chart, an xy chart. Now, x could be 0. 0 times 2 times 0 is 0, so y would be 0. But if x were 1, 2 times 1, if I put a 1 in for x, 2 times 1 would be 2, so y would equal 2. If x were 2, 2 times 2 is 4. And if x were 3, 2 times 3 is 6. 2 times 3 is 6, so y is equal to 6. And you can see this direct variation. As x gets bigger, so does y. Now, y happens to get bigger twice as fast as x does because we're kind of multiplying by 2. And it depends on what this constant k is. This is, again, the k. K is the 2. It's the number that doesn't change. The x and the y change each time. Let's see if I can make that k look a little better. Okay, so let me pause this and go get you a graph. Okay, so this is a little graph paper, and I need to get rid of that. Okay, so these are our points, x and y, and they look like, there we go. We have 0, 0 is a point. 0, 0 is almost like putting the parentheses around and adding the comma like that. 1, 2, 2, 4. These are points. And 3, 6. And each one of these points can be graphed here. This would be 0, 0. And over 1, 2 would be over here at 1 and up in a positive 2 direction, so it would be here. And then 2, 4 is going to be right here. This is number 2. 1, 2, 3. 1, 2, 3, 4. I wrote it in the wrong place. It's a good thing I double checked my work there. Let me see if I can erase it. Oh, I erased everything. That's no good. Okay, anyway, what I've got here is a line that's created, and the next line would go right through here at 3, 6, which would be this point right here. It'd be nice maybe if I had a bigger graph so that you could see my writing. I guess we could try again. Let me just delete all of this. Plus that. Okay. We'll try it again. I notice our book sometimes does it differently. We want to tell if it varies directly. And they give us a box. They put the x this way and the y this way. And then they put numbers in. When x is 1, y is negative 2. When x is 2, y is 0. When x is 3, y is 2. Notice how as our numbers are going up, these are getting larger. These numbers are also getting larger. And then the last one is 4 and 4. So we can see 1, 2, 3, 4, negative 2, 0, 2, and 4. So this is growing by 2 every time. And we can put in our graph again. Maybe this time we'll try to make it bigger, if I can remember how to make it bigger. There we go. And then move it just a little bit, and then make it bigger again. so that we can actually see what's happening. This is in our book, and we have to plot the points, draw a line through the points, tell whether x and y show direct variation. And we think that they do because 1, -2 would be over here, 1, -2, and then 2, 0 is this point. This is 1, -2, which is this first one. This is a point, and then 2, 0 is this one. And 3, 2 is come to 1, 2, 3, and up 2. And you can see basically we're going up 2 over 1, up 2 over 1. This is our rise over our run, and we'll talk more about that later. And then 4, 4. Oh, I didn't put that in the right place. 4, 4, 1, 2, 3, 4. So that matches up. 1, 2, 3, 4. Okay, it's this one. And I can draw a line carefully and get right through them if I do it just right. Excuse me. So the line does not pass through the origin. So x and y do not show direct variation. So see how we missed the origin is this middle point, this 0, 0. If it goes through the origin, we can use multiplication. We can use some sort of constant k to write a formula for this. The next one, B, example B, does go through the origin. We can see it goes through 0, 0. Let's go ahead and put this back in here. Make it nice and big. Move it over a little bit. Okay. This gives us x and y. And again, it does it sideways. I kind of like to do it vertically because then I can see my points better. 0, 0, 2, 2, 4, 4, and 6, 6. Those become the points 0, 0. I can put that in at the origin. And the points 2, 2, you can kind of follow this. Over 2, up 2. Over 4, up 4. Over 6, up 6. And you can actually count 1, 2, 3, 4, 5, 6 just to make sure I'm doing it right. And 1, 2, 3, 4, 5, 6. And they line up nicely. Now, according to the book, it has direct variation because it goes through the origin. And as the x grows, the y grows equally. So the first one I showed you was y, oops, change it over here, y equals 2x. So for every 1 that the x grew, the y grew times 2. This one, it's going up 1 for every 1, or 2 for every 2. So the formula here, the equation, would be y equals x. That's just how that looks. Okay, so let's go on to the next example. Let me erase this real quick. There we go. All right, so it has to follow the form y equals kx. We can graph it if it doesn't, but it's not direct variation. And if it's in this form, it's going to go through the origin. That's going to go through 0, 0. So letter A on example 2 says y plus 1 equals 2x. See, this matches, the y matches, and the k would be 2, and the x would be x, but there's this extra 1 that shows us that it does not. No, it does not. Cannot be written as y equals kx, so x and y do not show direct variation. And for letter B, it has 1/2 y equals x. And this doesn't look quite right, but we could probably mess with it to make it look right. What I would do is I would go ahead and I'd multiply both sides by 2 over 1 to get the y by itself. When I do that, and I rewrite it, those cancel out. It just leaves me y is equal to x times 2, which really should be written y equals 2x. And again, then we do have it. So this would be not no, but yes. This has direct variation because it follows our form. Y equals kx. Our constant k in this case is 2 again. That was that one that we already did. Now, sometimes they're just going to give you a chart and ask you to tell. They're not going to give you a graph. And we can erase one more time. They give you, oh, those are on your own. I'm going to let you do those. Okay, very good. The height of a television screen, let's see if I can do this. It's got, looks like that, and the length is x, and the height is y. And it says that it varies directly. And then it also says that y is equal to 9 over 16 times x. So what would the height be if the width were 48 inches? So the width is 48 inches. How would we solve for what the height is? See, it's always proportional when we have an equation like this. And it doesn't matter what size the TV is, but it's always going to have a proportional height versus length. So we put this in. It looks like this. Y is equal to 9 over 16. Instead of times x, it's going to be times 48. Times 48 ones if you want to write it like a fraction. Now the question is, does 6 go into 48? 16 go into 48? Well, 16 times 1 is 16. 16 times 2 is 32. And 16 times 3, 32 plus 16 is 48. So it does. So this actually should be simplified down to 3 ones. It takes 3 16s to get 48. And then we're going to just multiply straight across. 9 times 3. Let me change colors so that it doesn't get quite so confusing. Always just have to do that. It looks better. 9 times 3 is 27, and 1 times 1 is 1. So 27 should be the answer. 27 inches is what y is, so y is equal to 27. If we had a 48-inch TV screen this direction, 27 inches would be the height. Usually we measure television screens along the diagonal, but we're not talking about diagonal, the size of the screen. We're just talking about how the width and the height vary directly. They change. As this, if this were to get longer, this would get longer too. You could have a small TV and you could have a large TV, but they should be proportionately the same. So if this is 2, whoops. If this is 2 and this is 1 and this were 4, this would have to be 2. You can see that it's twice as big. And this isn't twice as big, but it's indirect variation. And that's kind of the point we're trying to figure out. All right, good luck.